Hello and welcome to my channel Tech Construct. In this YouTube series, The Road to Mastery, I start by teaching the fundamentals of a topic and diving deeper into said topic. This series will focus on React.js. In the description below, I'll leave a link to a document that I published that will set you up with a basic React project so that we can get started. In this section, we'll be covering some language basics. This is essentially a crash course in JavaScript. So if you're already familiar with JavaScript, you can skip to the basic structure of a React app portion, and that'll start the React portion. But if you're just completely new to programming, you have no concept of JavaScript, then this is a pretty good crash course here. When you have an application, you can write very simple applications. You can print out some stuff like what you see here. In JavaScript, this is a print statement, console.log. It prints to the console of your browser. But complex codes require what's known as a variable. A variable is simply a container for a value. JavaScript is known as a dynamically typed language, as opposed to a static typed language. Dynamic simply means you don't have to specify what the data type of a variable will contain, as opposed to static, which those types must be expressed. In JavaScript, there are 3 ways of declaring a variable, but one has fallen out of favor, simply because as of an update to JavaScript, the method of declaring a variable known as var, V-A-R, is no longer needed. That reason for that being is that before let and const came along, var created a number of different headaches. To fix those headaches, block scope variables were created. Let and const are both known as block scope variables, compared to var, which is a function scope variable. It's a really simple concept to grasp. All of this that you see here, this file here, can be seen as a block. So if I do let, which is a keyword, followed by variable name, this assignment operator, I can give it this string. Anything in single quotes, double quotes, or backticks is known as a string. I can declare that here, and I can use it throughout the code. Console.log, our output statement, will simply output, this is not a test. Now, block scope means that I can't redeclare this in the same block. Remember, this entire file here is one block. So if I were to do something like this, you see that there's an error popping up. Cannot redeclare block scope variable test string. But what you can do is create a block statement denoted by these curly brackets here. Now, inside of that curly bracket, you see the same thing, just a different string. But the string doesn't matter. If I were to just replace it with this, the same thing applies. The reason this doesn't throw an error is because this block statement is seen as its own block. It's a block inside of a block. If I were to do this, still works. If I were to do this, still works. Because these are their own blocks. This is a block inside of a block. This is another block inside of that same block. And this is a block inside of a block inside of a block. It's the same thing with const. Const is a block scope variable. You have the keyword const followed by the variable name. I chose pi, our assignment operator, and I gave it the value for pi. Console.log, and you will get the value of pi printed in the browser console. I can create a block statement and reassign it to the rounded up version of pi. And it's totally fine. But the difference between let and const being short for constant, is that let allows us to do what's known as a value reassignment, meaning I can do test string equals alakazam, and it's totally fine. If I were to save that and run the code, console.log test string will print out alakazam instead of this is not a test. With const or constant, you cannot do that. If I were to do this, save it, and try to run it, you would get a type error that would essentially kill the code. Kill the code meaning nothing past that line, nothing past line 14 would run. This is because const represents variables whose values are not supposed to change. So if you're confident that a variable won't change its value, then use a const. But if you need that variable to be reassigned at any point, you would use let. Now, this applies when we're doing basic data types. Basic meaning what we see down here. You see let num equal 2024. This is known as a number type. Let text, some basic text, a string type. Decimal, in some languages, this is known as an integer. 2024 would be known as an integer, as opposed to 3.50 or anything with any value with a decimal in it would be known as a float or a double. Some languages, this is denoted by putting an F at the end, but JavaScript doesn't do that. JavaScript, these are just known as a number type. Our next value, let is root equal true, is a Boolean type. Booleans are just used to represent, at their core, 0 or 1, off or on. It is a computer's way of knowing if something is true or false. Let has admin rights is false, also a Boolean type. On line 25, I've declared a game list, which is an array of some of my favorite video games, which is an object type. On line 26, we have a book object, which contains one of my favorite books. We'll go into further detail about objects down the line. There is also a new type that I wasn't really aware of until I was making sure that I had everything I needed for this video. And that is a symbol type. You use a symbol type when you want to create something unique. So for instance, if you were to create an identifier for an object and you want to make sure that that identifier was unique, you might create what is known as a seed, do some calculations and generate an ID. Well, there is the possibility, small possibility, depending on how you implement it, that you might get the same number and two objects end up with the same ID. Well, it wouldn't really matter because symbol's job is to make sure that those two values are going to be unique. You also have a null type. Create a null variable here. Let null var equal null. Null is a keyword. There is a function in JavaScript that you can call called type of. Type of just returns what you see up here. So if I were to place num here instead of null var, type of, well, null var, you would have to change this as well. Let's just pretend this as type colon, whatever the type is. Type of num would be a number. Type of string would be a string. Boolean is Boolean. Object is object. Symbol is symbol. But null type type of will return an object. You also have an undefined type. Let missing no equal undefined. On line 40 here, we have let empty, where we don't do any assignment. Well, if we don't assign anything to it, it's automatically an undefined type. As you can see here, type of missing. Sorry, this should be empty. I changed the name. Type of empty. Type of empty. I'll just go ahead and change this here to prevent confusion. Type of empty is undefined because we haven't given it a value. Functions are blocks of code that can take in parameters that you see here and perform a series of statements. Functions can also have a return type. To declare a function, you use the keyword function followed by a function name. The typical convention for naming your functions, as well as naming your variables as well, they should be what's known as camel case. The first letter is lowercase. So for instance, you have add. Add is in lowercase. Add numbers. The N in numbers would be capitalized to create a camel case. Try to make your variable names and function names as descriptive as possible. Here in this function that I've declared, I have it take in two parameters. Parameter A, which will default to 0 if nothing is given, and B, which if nothing is passed in, will get assigned 0. A general rule of thumb is that a function should do one thing and do it well. Here we have add numbers, meaning the only thing that this function should be doing is adding numbers. It shouldn't be doing random multiplications, divisions, or trying to read a file to update the date in the file. In our function, we have a const that we call sum, and that sum is simply the addition of the two values that have been passed to this function. We'll also print that sum out, and we'll return that sum so that whatever calls that function can make use of it. Down here, we have calling a function. To call a function, you simply use its name and pass in whatever values that it takes in. Line 54, add numbers. We pass in 110, 389, and this will return the sum of these two numbers. The same thing happens for add numbers, 28.4 and 80. It just adds that sum, outputs it in the console, and returns the sum. Here on line 56, we just simply pass in 458. Remember up here where I was talking about these values that we assign by default? Well, this here, this 458 will get passed into this A parameter. B will default to 0, meaning if we call this method, the result, the sum, will just simply be 458. There's more to functions, but we'll cover that later because there are some other things that we'll need to cover down the line. The next thing we'll go over is destructuring. Destructuring is a JavaScript expression that unpacks values from arrays or the properties and objects into distinct variables. Here, we create an array of colors. I have a number of different variables, opt1, opt2, opt3. Since we're destructuring an array, these values that I want to pull values from here and place into these values here will be surrounded by regular brackets. So we have let, open bracket, opt1, opt2, opt3, close bracket, assignment operator, colors. What this is saying is from colors, our array here, we want to take the value of the first index, red, and we want to assign that to our first variable here. Our second variable, we'll get the second value in our array at index 1, and opt3 will get the value at index 2. To note, in computers, you start at 0. So this is index 0, index 1, 2, 3, 4. But the length of this, if you were to call colors.length, would be 5. Down here, I'm just simply outputting the values for the variables that we created up here. Option 1, we have the string option 1 here, and plus opt1. This is another way of outputting data known as string concatenation. What you're essentially doing is you're taking this string here and you're adding this string here to it. So what this should actually read is option 1 red, option 2 gold, option 3. Output option 1 plus opt1. Option 1 is red, option 2 is gold, and option 3 is emerald green. Now, there is a way to skip certain values, as we can see here. You don't need to put these comments here. You'll see when we get to this portion here. We'll break this down line by line. Well, piece by piece. We have this comment here, empty, comma, another comment here, comma, opt1, comma, another comma, followed by opt2. If we do console.log option A plus option opt-A here. Opt-A will have emerald green. Why is that? Because this lone comma here, remember, comments are ignored. So pretend that this isn't here. This is more so that someone reading it will know what's going on. This comma here means we're going to skip. This comma here means we're going to skip gold. And then we're going to assign emerald green to opt-A. Now, this comma here is to denote a separation between opt-A and opt-B. What this comma here does is tells us to skip black. So opt-B will get scarlet. Me personally, I find it easier to put things like this in because it helps to visualize it a bit more. I typically take to putting these comments here, just to once again note that I'm going to be skipping this. I'm going to be skipping the first, I'm going to be skipping the second, I'm going to take the third, and I can do this here. And it'll be the same thing. When it comes to objects, we see here, I've created a constant Persona 5 data. And this is just information about the game Persona 5. When it comes to objects, destructuring can happen in two ways. Option 1 is destructuring in a function parameters. What we can do here is, if we're supposed to pass in an object, what this translates to is inside of that object that we pass, pull what the name is, the name Persona 5 here, pull the year, the string 2017, miscellaneous. We have this object here, but we're also going to destructure that as well. So this right here just means take the characters. So this array here. We come down here to line 87, console.log name. That name will just be the name of the game here. Console.log year. It will just be the year here. And since characters is an array, we'll need to loop through in order to print the values there. So loops are something that we'll go into more details, but what this is a for loop. In a for loop, you can do declaration of a variable. We see here const character of, which is a keyword, characters. What this translates to, for every value in characters, take each of those characters and loop through them. You have Joker, Morgana, Fox, Queen, Oracle, so on and so forth. Take this value and assign it to character and loop through each of these values until we run out. On line 91, we just output what that character is. Now, this is how you do it when you're passing in an object as a function and you just want to pull specific things, because you see, we also have genres, which we don't print out. Option 2, we just simply want the name and the year from Persona 5 data. Since we're destructuring an object, instead of using the brackets that we have up here, as you see on line 64, we're going to use curly brackets instead. So we have let, in curly brackets, name, year, assignment operator, Persona 5 data. Console.log, option 2, name, and we pass in this name. Option 2, name, Persona 5, option 2, year, 2017. Option 2 is the equivalent to, if we were to just take Persona 5 data and do what is known as dot notation, name, which gives us the same value, year, which gives us the same value. You can use whichever method feels comfortable for you. Personally, I tend to use option 2A just because it's what I'm used to, because JavaScript wasn't my first language. That would be C++. And this is how we typically referenced properties of an object. To close on destructuring, think of destructuring as just a means of pulling what you need and leaving what you don't. The next topic we'll go over is arrays. So at this point, we know how to declare an array. Const or let, some name, assignment operator, brackets. Brackets denote an array, and we give it some values. We've mostly dealt with strings in our arrays, but arrays can contain whatever values you want. Typically, you'll have things like an array of strings, an array of numbers, an array of objects. But JavaScript doesn't care if you do something like this. Arrays in JavaScript can have mixed value types. But once again, you typically stick to one type just to make things easier on yourself. Arrays in JavaScript have built-in properties and functions that we can make use of. One such property is the length, which gets us the length of an array. So console.log grocery items needed grocery list.length gets or sets the length of an array. This number is one higher than the highest index in the array. Remember when I said earlier that computers start at 0? So we have index 0, 1, 2, 3, 4. To get a particular item from an array, you can use what is known as bracket notation. Console.log item 3, grocery list, get us number 2, or item 3, which will print out item 3 is flour, because we say we want the value at the second index. Remember, index 0, index 1, index 2. We can even modify an item in an array. We have grocery list item 4. We're going to change that to brown sugar. Console.log item 5, grocery list index 4, 0, 1, 2, 3, 4. But we change sugar to be brown sugar. So item 5 will be brown sugar. We can add items to an array via the push method, grocery list.push. We're adding vanilla extract. Push also returns something, returns the updated array length. So the updated array length will be 6. We're also going to put fish oil in our array. We can find the index of an item using the index of method. We have let flour index equal grocery list.index of flour. What this method will do is it will look for this specific string. 0, 1, 2. 2 gets assigned to our flour index. Console.log flour is item flour index plus 1. Flour is item 3, because we as humans would see this as 3, not 2. We can even remove items from an array. And there are 2 ways of doing that. So I wanted to print out what the contents of this grocery list is before. Before, we have apples, rolled oats, flour, butter, brown sugar, vanilla extract, and fish oil. The first way of removing an item from a list, an array, is using the pop method. Pop simply removes the last item in an array. Grocery list.shift removes the first item in an array. This line here is a copy of line 124. And the reason I did that is because this is no longer correct. Because remember, we remove the first item. The value of flour is at index 1. We have to get this again. And to remove a specific item from a list, we want to remove flour from the list. Grocery list.splice flour index 1. Splice is another function of an array where this first number here, flour index, that denotes the index that we're looking for. So we go to index 2. The second number here denotes how many values we want to remove. So we just want to remove the 1, which is flour. So what we do is we'll pretend this apples isn't here. We'll go to rolled oats, go to flour because flour index is 1. And then we say remove 1 variable from that index. We just remove flour. Now console.log after our list is rolled oats,
butter, brown sugar, vanilla extract, and that's it. We've gotten rid of fish oil, we've gotten rid of apples, and we've gotten rid of flour. One way to think of an array is like a queue. Imagine you're at a line at a restaurant of your choice, Panera Bread, Panda Express, whatever have you. There's a line of customers. Think of push as a new person coming into that queue. Notice that when we pushed vanilla extract, they went to the end of the list. 0, 1, 2, 3, 4. We add vanilla extract, and we added fish oil. Pop, removing the last item, the customer that just came in, they left. Shift could be seen as the first person in the queue left. Our next topic of discussion will be conditional statements. First, we have logical operators. We have the AND operator, which is denoted as ampersand, ampersand. Given a condition A and a condition B, this conditional statement will return true only if condition A and condition B results in a true. If either A or B results in a false, then the entire statement is false. We have our OR operator denoted as two vertical bars, which is given in condition A or condition B, the result of this condition statement will be true if one or both conditions returns true. If one is false, that's totally fine. We only return false if both conditions are false. Finally, we have our NOT operator, which is denoted by a singular exclamation mark. Given a condition, if that condition returns true, we return the inverse, meaning not true would equal false, not false would equal true. We also have comparison operators. The first operators we'll go over is the triple equal or strictly equals. What this means is in JavaScript, if we have two variables, if we have variable A equals variable B, what this means is we're checking to see if variable A not only equals the same value as B, but we're also checking to see if they are of the same type. Meaning, let's say we have the number 1 and the string 1. This results in a false, as opposed to if this was 1 strictly equals 1, then this results in a true, because the number 1 is equal to the number 1. We also have the strict inequality operator. What this does is the same thing as our strict equality, it just inverses it. If you have 1 strict inequality operator 1, this will equal false. The reason being is you can take this here and put it as not equal 1 strict equals 1. You're just doing the inverse. Everything that happens inside of the parentheses will happen first. So we check to see if 1 strictly equals 1. This is true because both values are 1, and the types of both 1 and 1, the numbers 1 and 1 is a number. So that checks out to be true. Then we inverse that, as we see with our NOT operator here, which returns us a false. There are two others that are missing here, equals and not equal. The equals operator is the same as our strict equality operator. The only difference is this doesn't check type. So for instance, 1 equals string 1 is true. It comes down to the same thing, 1 and 1. It's just that this 1 here is a string. Like the strict inequality operator, you can look at this statement here as 1 does equal 1, inverse, it doesn't equal. So what's inside of the parentheses returns a true. We inverse that, making it false. Next, we have our less than sign and our greater than sign. Easiest way to picture this is if you think about numbers. Is 2 less than 4? It is, right? So this statement will return a true. If you change this to the greater than, you ask, is 2 greater than 4? It is not, so we return a false. We have our less than or equal to and our greater than or equal to. What this translates to is if I have 2 less than or equal to 2. 2 is not less than 2, but it is equal to 2. So this results in a true statement. The same way, if I were to inverse that and ask, is 2 greater than or equal to 2? The result is the same because they are equal. But if I replace this with a 5, I'm now asking, is 2 greater than or equal to 5? Which is false. I have a note here, since we're talking about what results in true and what results in false. Any value that's not false, undefined, null, 0, nan, or an empty string returns true when checked as a condition. One thing that you can commonly see is something like this. Let's say we have a variable. We'll call it empty2. If you remember our lesson from before, this just creates an undefined variable. If I were to say if empty2, this results in whatever we're supposed to do between these curly brackets happening. Why? Because any value that's not false or undefined, our empty2 is undefined, returns a true when checked as a condition. That if statement that you just saw me use, we'll go over now. That's called a standard if-else statement. If is a keyword. To make an if statement, what you'll do is using the if keyword in parentheses, some condition. Recall line 20 from above. I put that here. We have a variable is root is set to true. Our condition results in true. If true is what this basically says. If our statement results in a true, then we perform this. You see here, we have a simple print statement. User has the keys to the kingdom. Do root stuff. We also have else. Else, we print out a statement. User is not root. Deny whatever it is that they were trying to do. To simplify this, an if-else statement the if-else statement takes a condition. We check that condition. If that condition results in true, we execute whatever is in the if block. If not, then we perform whatever is in the else block. You also have if else if. Say we have this variable here, state flag on. If state flag strictly equals on, then we do whatever it is that we're going to do. Else if, we also check this condition, state flag strictly equals off, do something else. Else if state flag equals pending, strictly equals pending, do something else still. Else, we have our fallback case. What this reads as, given our state flag, we know that it's on. We check to see if state flag equals on. It does, so we'll do this, and we ignore the rest of these statements. Now, what if our state flag was processing? Well, we don't have a condition for that. So what would happen is if state flag strictly equals on, that's not the case. So we move to our next statement, the else if, where we check if the state flag strictly equals the string off. That's not the case. So we move to the next one. Else if state flag strictly equals the string pending. That's not the case also. Else, we fall back to this case here. To sum up how this works is we go through each of these cases to check for a true statement. If we don't find it, then we do our else statement, which can be seen as a fallback case. The moment we find a condition that proves true, we just stop. We also have switch statements. Switch is a keyword. So to create a switch statement, we start with the switch keyword, parentheses, some condition. We have our condition state flag. What that does is using the keyword case, as you see here, I have three cases: on, off, pending, and we have a default case here. I did this to mirror our if else if statement up here. These do the same thing. You see our cases here. To denote a case, we use the keyword case and whatever that case is going to be. This here is equivalent to this here on line 73. What this is basically saying is case if state flag equals on, if state flag equals off, if state flag equals pending, if not, then do whatever this default case is. To separate our cases, we use the keyword break. Now, switch statements do not have to have a default case. In that case, if state flag doesn't equal on, off, or pending, we just don't do anything. You can also put a break here, but it's not required. Another conditional statement is the ternary operator. Ternary operator is denoted with this question mark. So you have a condition, question mark. Whatever that condition is, if it results in a true, we execute whatever is on the left side of this colon here. If our condition is false, then we execute whatever is on the right side. This becomes very important for React development because there's the concept of conditional rendering, where in some cases you will see some people write conditional rendering statements like this. Let's say we have a function generate user table. For the sake of this example, let's just pretend this returns some fancy table. I have an array of users. That array has 3 names in it to denote 3 users that we pull from a database. I have the condition that if users.length is greater than 0, meaning we actually have data to put inside of a table, then we're going to call our generate user table. which would ideally return a component in order to be rendered on the screen. If not, then we just return a null. So again, what this is saying is, if we have users, as in our users array, the length of it is greater than 0, then we'll generate a table. If not, we'll return a null. So if I were to make this 0, we did a search in a database, there were no users, then the length is going to be 0. So this condition will be false because 0 is not greater than 0. Thus, we'll return null. The next topic of discussion will be loops. A loop is nothing more than a block statement that gets done repeatedly based off of some condition. You have many different types. You have for loops, while loops, do while loops. We'll start with the more common one, the standard for loop. The syntax for a for loop is we have the keyword for, as you see here, an initialization step, a condition, and an afterthought. And we also have this statement here. For initialization step, we will create an index and assign it the value 0. Our condition is while the index is less than gamelist.length. I went ahead and pulled our game list from the top and brought it down here. While this statement proves true, execute this, which is our print statement, which is printing out game title v1, game list at index. So we start at 0, game list.index, index is 0. So we print game title v1, Final Fantasy 9. Once our statements, which is anything in between these blocks, as finished executing, our afterthought kicks in, which is index plus plus. Plus plus just means add 1 to this index. You can also do minus minus, but I've rarely ever seen that used. So index plus plus. So now index is 1. So index, which is 1, is less than game list length, which is 3. So this proves true. So we come back down here and print game title v1, game list index 1, which is Persona 5. Afterthought, index plus plus, put that back. So now we're at 2. 2 is less than 3. Execute again. Game title v1, Legend of Zelda, Tears of the Kingdom. Afterthought, index plus plus, index is now 3. 3 is equal to 3, so this condition is now false, meaning we stop printing this statement. Another version of this is the for of loop, which is pretty much the same thing. We just skip the initialization. And we don't have an incrementer to worry about, mainly because that's being handled by this syntax. So we have for, we're going to create a variable called game, and of the game list that we have, this list right here, we're going to do the same thing, except it's game title v2 followed by game. What this is, given a list, we're going to one by one go through this list and assign the value to whatever we create on the left side of. So we have Final Fantasy 9 first. So game is going to equal Final Fantasy 9. We print this statement. We go to the next value in our array. Game now becomes Persona 5. We print the statement out. We go to the next game in our list. Tears of a Kingdom gets stored in game, and then we print that out as well. The next loop we're going to go over is a map. So as you see here, I have a function called toUppercase, which takes in a string and returns string.toUppercase, which is just a built-in string function which takes any string and makes it all uppercase. I create a constant uppercase games equals gameless.map, and I'm passing in our function. What map does, as you may be able to see on my screen right now, calls a defined callback function on each element of an array and returns an array that contains the results. We have a parameter callback function, a function that accepts up to 3 arguments. The map method calls the callback function one time for each element in the array. What this means is game list, given our game list up here, we're going to iterate over our list. Final Fantasy 9, Persona 5, Tears of a Kingdom. We'll start with Final Fantasy 9. We're going to pass Final Fantasy 9, the string, to this uppercase function, which we've declared here. Function to uppercase, we pass in Final Fantasy 9. What we're going to return is string to uppercase. So all this will be uppercase. This gets stored so that it can be put inside of another variable, which we have here. We iterate, we go to the next function. We go to the next string in our array. Persona 5 gets uppercased. Tears of a Kingdom gets uppercased. The return, I print it here. If you were to put this exact code into Firefox or Safari or Edge in their browser console, you'll most likely see this syntax here, array 3, which denotes we have an array which has 3 elements in it. And what's inside of that array is this here. As you can see, all of our strings have been uppercased. That's now what's contained inside of uppercased games. We also have a filter function. Map and filter are just built-in functions for arrays. We have a constant called numbers, and we give it a series of numbers. We create a function is odd number, which is just checking to see if the number that we pass in is odd. We also have another function is even number, which just checks to see if a number is even. The way you can do that, if it's odd, number modulus operator 2, which is basically saying, is the number divided by 2, is the remainder equal to 0? 10 divided by 2 is going to be 5. There is no remainder, so it would be 0. Then this would be true in our is even number function. So we know it's an even number. But if we take 13, well, the remainder for that is going to be 1. So the statement in our is odd number function is going to be true. So that denotes it being odd. Now, with those two functions, on line 243, I'm going to create a constant odd numbers, and I'm going to create another constant even numbers on line 244. Numbers.filter we see here, assuming you can see this block on my screen, filter returns the elements of an array that meets the condition specified in the callback function. Params, a predicate. A predicate is a function that accepts up to 3 arguments. The filter method calls the predicate function one time for each element in the array. So, similar to our map function, where our toUpperCase function was called for each of these values, on line 243, isOddNumber is going to be called for each of these numbers in our numbers array. So you have our function isOddNumber. The first number that's going to be passed in is going to be 10. So we're asking, is 10 modulus 2 not strictly equal to 0? This results in a false, because not strictly equal to is the same thing as asking, is 0 strictly equal to 0? This is true. Inverse it. So false. Since that results in a false, isOddNumber returns a false, which means we skip this 10. The same thing happens for 28, because 28 modulus 2 is going to be 0. Same for 58. But here at 13, we're going to get a remainder of 1. So we're asking, is 1 strictly equal to 0? This is false, because 1 does not equal 0. And then we inverse it, so that's true. So since we're returning a true with our odd number function, 13 gets put inside of our odd numbers array. The same thing happens for 97 and 53. 20 gets skipped. As you can see, I printed out the statements down here. Odd, let's print out what's inside of the odd numbers array, is 13, 97, and 53. We do the exact same thing, but with this condition, number modulus 2 strictly equals 0. Line 244, we're filtering out all of the even numbers. At the end, console.log, even, printing out the even numbers. Even numbers are 10, 28, 58, and 20. Now, you've seen the keyword break, but we also have a keyword called continue. Break means when we encounter this, exit the loop entirely. We have index is equal to 1 as our initializer. We have the condition, while index is less than 10, we want to check to see if the index modulus 2 is strictly n equal to 0. If that is the case, we print out the statement break test index, else break. Since we're starting off with 1, we're asking, is 1 divided by 2, is the remainder of that strictly n equal to 0? This is true because 5 does not equal 0. As you see here in our print statement, we print break test 1. Our afterthought, index plus plus, we go to index equals 2. Index, which is 2, is less than 10. So we're asking, is 2 modulus 2 strictly n equal to 0? This results in a false because 0 strictly equals 0. And we inverse that. So that becomes false, which means our else statement now executes, which is a break. That's why here you only see break test 1. Once we hit a break, we exit that loop entirely. This works in cases where if you run into some condition that might break your code, if you continue in this loop, you can break out of that loop and continue on to do whatever else it is that you're going to do. Sometimes you may not want that. Sometimes you may just not want to do whatever it is that you're doing for that particular index. That's where continue comes into play. We have the same exact for loop, except instead of break, we use continue. With this for loop here, it's almost a mirror of our break for loop, but the difference is we're checking for even numbers. So you see down here, continue test 2, 4, 6, and 8. This is because we start off with 1. 1 is less than 10, so we come down here. 1 modulus 2 is 5, so we're checking to see if 5 equals 0 strictly. That's not the case. Else, we just continue. For every even index, we print out our statement. On odd numbers, we just continue, and we don't do anything else. Some other loops we have: while loop and do while loop. For a while loop, we declare our index outside of it. So we create this index 0, and we say, while index is less than 10, do something. Our afterthought is also inside of where we would normally put our condition. Where we would normally put our statements. Index plus plus. Index is now 1. We keep doing whatever it is we're doing. A do while loop, on the other hand, is denoted as such. You have the keyword do, our brackets, some statement, something that we're going to do, our incrementer, while our condition. Something to note: if you just get rid of this and you run this code, eventually your program is going to crash. Your browser will freeze up, things of that nature. Like, it's not going to be good. The reason being is you're basically saying, by getting rid of this, do the statements that are inside of here. Once that's done, we come back to our condition. Nothing has happened to our index, so it's still 0. So you're saying, is 0 less than 10? Yes. Do this. Come back. Is 0 less than 10? Yes. Do this. So on and so forth until your application just crashes. This is for every programming language. That aside, the difference between a while and a do while loop is we check our condition first in a while loop before we do anything. The result of this will be, let's just say, do something, which is print out the index. We would be printing out 0 to 9, because once index equals 10, this statement becomes false, and then we stop. Prints 0 to 9. On the other hand, with a do while loop, we do our statements first, then check the condition. What this will result in is we print 0 to 10. The reason being, on index equals 9, we check 9 is less than 10. That's true. Come back and do our do while. Come back into the statement. Print out 10 because index is now 10. Now index is 11. We come down here. Index, which is 11, is less than 10. That's false, so now we stop. When it comes to loops, most of the time you're going to be using a for loop or some variation of it. For statements, for in, for of, for each, because it results in my opinion, cleaner code. While loops have a place, it's just, I can't think of a reason why you would use a for loop or you would use a while loop over a for loop. Even rarer is a do while loop. As I had stated earlier, we're going to revisit functions for a bit. There's the concept of an arrow function. If you remember where we were using the map function, let's say I create a constant upper game list. And that game list in our map, we're going to pass one such arrow function. What you have here is parentheses, game, arrow notation, which is just equal and a greater than, curly brackets, return game.toUppercase. What this is you have an anonymous function because this is a function that has no name. That function takes in a parameter called game. And in that function, denoted by these curly brackets here, we're going to return game.toUppercase. What we essentially did was replace the uppercase function that we created before with an anonymous function. In fact, you can even get away with this because it's just a single line. We're going to print out uppercase games is upper game list. You get the exact same output as when we gave a named function as the callback function. Same thing can happen with filters as well. Even number filter, we're going to pass in an arrow function. That function is going to have the parameter named num. And what we're going to do is return num modulus 2 if that is strictly equal to 0. So basically, we're checking to see if in our numbers array, we're going to check for all of the even numbers. The next topic we'll discuss will be objects. We have been dealing with this for a while now, actually. I'm creating a person object. That person has a first name and a last name. We give it the value of string. There are two ways to access the properties inside of an object. You have what's known as the dot notation, which is the name of your object dot whatever that property name is. If we output person.firstname, you'll see Moira. There is also the bracket notation, which is just to note it the object name, open bracket, passing in a string, property name, which results in the same thing. These properties can, of course, be updated using either notation. Person.firstname equals Charles. So person.firstname is now Charles. We can add members to an object as well. I want to create a nickname. Person.nickname equals Professor X. I put a note here that all of what you see up here can be done with the bracket notation as well. So person.nickname equals Professor X is equivalent to person bracket nickname equals Professor X. Printing that out, person.nickname is Professor X. Now, when we're talking about objects, there's the concept of this. The value of this depends on the context with which it's used. In the context of an object, this refers to the current object that is being utilized. So for instance, I've created another person, person2. I have a function, introduction. That introduction function just outputs I'm this.firstname, this.lastname, aka this.alias. This refers to this object dot first name. So first name is T'Challa. This dot last name, Udaku. This dot alias, Black Panther. I created another person, the first name Franklin, last name Richards, and then at introduction, that is the same method that we see above. But once again, this refers to the first name of the current object, which is person, well, in person 3, which is first name Franklin, last name Richards, and alias is Powerhouse. To call a method inside of an object is much like referencing any property in an object. The object name dot function with our brackets. If there are parameters here, we pass them here as well. Here I've put the output of what introduction returns. You may hear function and method used interchangeably. They're not exactly the same thing. Methods are defined within objects, classes especially, which we'll go over in a second. Functions are declared anywhere else. Methods are defined in objects, functions are not. The last bit will be a discussion on classes. To create a class, we start with the keyword class, and then we give a name for that class, followed by our brackets. Normal convention is when you're creating a class, the class name starts with an uppercase letter. So you see here, person as opposed to person, all lowercase. Inside of my class, I have a property name. I have what's known as a constructor, and I have a method. Your constructor is a method that is used for initializing your class. As you can see, my constructor takes in a name, and inside of that constructor, this dot name, this object, this referring to whatever object we instantiate of this class, its name will equal whatever name we pass into the constructor. Introduction, we output I'm this dot name. When it comes to classes, we also have the concept of inheritance. If I want to create a class called superhero, the extends keyword denotes that superhero is a child of person. We see above, person is a class that we've created up here. Child classes can have their own properties and their own methods. They also inherit the properties and methods of their parent. Child classes can also have their own constructors, as we see here. Since we have a name property in our person, and we have alias in our superhero, our constructor, name, alias, note the first line in our constructor for the child class is super passing in name. What this is saying is, call the constructor of the parent and pass in this name. That sets the name for our parent class. The next line, this.alias equals alias, sets the alias for our superhero. What we have here, introduction, is an overwritten method. you see our method here, introduction. These have the same method signature. These are two void functions that take in no parameters, both name introduction. So when two methods have the same signature, what you're doing is overwriting a method. So our overwritten method, instead of just saying I'm this.name, our superhero class will print I'm this.name, aka this.alias. Our child class also has its own method, hideIdentity, which outputs I'm this.name and I'm not this.alias. To make use of our classes, we'll need to instantiate an object of that class. To instantiate an object, we have let normal person A, our variable name, equals new, which is a keyword in every language that I've ever used, which denotes we're going to instantiate an object of the class person. Person, as we see in our constructor up here, takes in a name. When you have new person, what this is doing is calling the constructor. Miles Morales is the name that will be passed into the constructor. So when we call normal person A dot introduction, the output is I'm Miles Morales, which is the function, which is the output from the parent introduction method. But when I create superhero A, let superhero A equal new superhero, Miles Morales, and Spider-Man. What we're doing is calling the constructor for the superhero class, which sets Miles Morales as the name inside of a parent class and Spider-Man as the alias in the superhero class. So when you call superhero.a introduction, we call the introduction method that is inside of our superhero, which is I'm Miles Morales, aka Spider-Man, is the output. We can also call superhero A dot hide identity. I'm Miles Morales and I'm not Spider-Man, which is the output. The last topic for discussion in our language basics is the concept of encapsulation. Encapsulation is a fundamental concept in object-oriented programming. This refers to the practice of hiding internal details of an object and exposing only the necessary information to the outside world. Encapsulation helps in maintaining the integrity of data and ensures that it is not accessed or modified inappropriately. To denote a private variable, as in a variable that should not be used outside of a class, we put the hashtag sign in front of that variable name. So as you can see here, we have a student class, which extends person. So we created a child class student with the parent class person. The constructor, name, social security number, super, of course, this must go first. In every child class constructor, this must be the first line. Super passing in name, and then this dot hash sign social security number equals whatever we pass in for the social security number. We can also create private functions. Print social security number as a private function. Console.log SSN is this dot SSN. If we instantiate a new object of student, let student equal new student, passing in Nicholas Tink and your social security number here. This works just fine. However, if you were to try student.print ssn, this would not work because this method is not defined. If you were to try this also does not work because property print ssn is not accessible outside class student because it has a private identifier. With all that being said, we have just gone over a crash course of JavaScript, so now we can move into the React portion of this course. In this section, we're going to be covering the basic structure of a React app. In either the link or the pinned comment, depending on which one I can actually do, I'll be posting a link to a document that I have that will help you get your project set up. This portion here assumes that you have read that document or you were able to set up a project on your own. So we'll be going over what the basic structure of a React app is. Let us start with the node modules folder. This is a folder that gets created when we run create React app. Node modules contains the dependencies needed for our app to work. Those dependencies are the basic React dependencies and whatever dependencies that you specify in your package.json file. As you can see, we have a few dependencies here. We have React version 18.2.0, React DOM, React scripts, Web Vitals, and that's about all that gets created as a bare bones React app. Next, we have our public folder. Our public folder is a root folder that gets deployed as our React app. The most important file here would be this index.html file that you see on the screen now. Some key things to point out. We have here the title. So if you ever want to change the title of your web page, you would change that in your index.html file. And the most important line is the line here. Div ID equals root. This is going to become important really soon. The index.html file is a template file served when we start our app. Try not to create multiple HTML files in your public folder. Instead, you should be creating components, which we'll also go over. Next, we have our source folder, which contains essentially the vital organs of our app. Our components, tests, stylings, and things of that nature. Important files to note here are our index.js file, as well as our app.js file. Index.js renders our component, whereas app.js is the basic component created by default. By default, it just creates a spinning logo. As you can see on the screen, I've cleared out the basic code because I'm assuming you want to see more than just a spinning logo. This greeter that you see here, we're going to cover really soon. To explain what you're seeing here inside of this index.js file, we're going to discuss rendering. Let's go over the concept of rendering in React. This is done in 3 steps. The first step is triggering a render, second being rendering the component, and third is committing it to the DOM, it being the component. When it comes to triggering a component, there are 2 reasons for that component to render. The first is the component's initial render. An initial render occurs when the app first starts up. The second render, the component or one of its ancestors' state has been updated. In regards to that initial render, this is done via the create root method that we saw in our index.js file. As we can see here, we have React DOM.create root, where we pass in a DOM node, that node being our root node, and then calling its render method with our component. As we see here, root.render passing in our React component. In step 2, React renders our components. After triggering a render, React calls our component to determine what to display. Rendering React is just simply calling our components. Remember, our components are just functions. On initial render, React will call the root component. For subsequent renders, React will call the function component which triggered the render. This is a recursive process. What that means is, if the updated component returns some other component, React will render that component next. And if that component also returns something, another component, it will render that component next. And this pattern continues until there are no more nested components and React knows what all to display. Something to note here is that rendering must always be a pure calculation. Else you run into some confusing bugs and some unpredictable behaviors once the code grows in complexity. Strict mode helps a lot with this. In our final step, React commits changes to the DOM. After rendering or calling our components, React will modify the DOM. For the initial render, React uses a DOM method known as appendChild to put all the nodes it created on screen. For re-renders, React will apply the minimal necessary steps during the rendering to make the DOM match the latest rendering output. React only changes the DOM nodes if there's a difference between renders. A good example to help commit this to memory would be to imagine working in a cafe. Imagine React as the barista who puts in the customer's orders and brings them said orders. Those 3 steps that are done, triggering a rendering, could be seen as delivering the order to the kitchen. Rendering the component could be seen as preparing the orders in the kitchen, while committing to the DOM could be seen as handing off the order to a customer. Now, a re-render could be seen as, let's say, React has delivered the whatever component you've created to the customer, but the customer wants something else. Let's just say you gave them a red button, but they wanted a pink one. So React would take those instructions, go back to the kitchen, say, hey, I need a pink button this time. The kitchen returns the pink button and React delivers it to the customer. And you see a pink button on the screen now. Hopefully this example helps to better visualize this process because it is a very important process for React. In our component section, let's start by defining what a component is. A component is simply just a JavaScript function that utilizes markup. Why do we create them? As stated before, React.js encourages the usage of components-based UI elements. In this file, we're going to create a very simple component known as greeter. We're going to make that greeter available for use in our app.js file. To start, we'll start by creating a function greeter, and we're going to deconstruct and pull out a name from our properties that gets passed into our greeter component. Another way of doing this, if you've ever looked at React.js code before, you're probably used to seeing something like function, whatever that function is, in our case, greeter, props. What this is referring to is the props that gets passed from the parent component. The reason I typically opt to do things this way, where we're deconstructing it, is because through the process of deconstruction, which is a JS expression which unpacks values from arrays and objects, is because destructuring creates distinct variables that we can use. In this case, we're creating a variable name that we can update however we see fit, because props, which is something that we'll be going over in our next section, props are immutable. To get around that problem, make things a bit easier, I typically opt to destructure the props that comes in so that I can just simply make use of whatever I need. In our component, as you see here on line 11, we start by creating a date object. Date is just a standard class in JavaScript. The date constructor creates date objects, which is what we're doing here. new date, which is just instantiating a new object of date. Next, we want our date to look pretty. So we create a formatter and we assign it all these different properties. And what we're going to return is a div that contains a paragraph that has a simple greeting. Good, based off whatever time of day. So morning, noon, evening, whatever name that we supply. It is currently whatever the current time is at the time of running the code. As you can see here on line 28, one thing that's really good to get in the practice of doing is setting default props. To set default props, you simply take the name of your component dot default props equals some object. That object containing whatever props we're going to pass in, followed by some default value. Since we know that there's a name, we have a name property followed by whatever value that we want to supply as a default. So in the event that we don't supply any name, Clive Rosfield will be used. You can even do nickname test. You can add whatever props you want here. Lastly, we need to export that component so that it can be used by whatever it's going to be using said component. What we're doing here is creating a named export. You know it is a named export because of these curly brackets here. Named exports can export numerous things. So for instance, I can export this component here. I can also export our getTimeOfDay function. We can take a look into our getTimeOfDay function just to see what that's doing. Our getTimeOfDay function takes in an hour. That hour is 0 to 23. This is because 0 represents midnight, 1 represents 1 a.m., 11 represents 11 a.m., 12 represents noon, 17 represents 5 p.m., so on and so forth. We essentially have a series of ranges, 0 to 11, between 0 and 11, between 12 and 17, and between 18 and 23. Based off the hour that is submitted, we return morning to denote morning, afternoon to denote afternoon or noon, and evening to denote evening. And if for whatever reason we pass something that doesn't fall into this range, we return invalid. Exporting a component is all fine and dandy, but we also need to make use of that component. So as you can see here on line 2, I'm going to import my named export greeter from my components folder. Our component here, app, returns simply our greeter. And if we were to run that via the npm start, if you're using command line, or if you're using an IDE like WebStorm, like what I'm using here, you can just click the play button and it'll do it for you. What you'll see here is, good evening, Clive Rosfield. It is currently Monday, January 8th, 2024 at 10:28 p.m. Eastern Standard Time. Now, that is not my name. So we're going to pass in some props like so. We're going to put name equals Jonathan Creed. If we save that, we'll see good evening, Jonathan Creed, followed by our time message. Let's go over props a little bit more in detail. Think of props as just information is passed to a JSX tag. As you can see here, we have a prop name, and we give it name Jonathan Creed. As mentioned before, props are immutable. Immutable just means unchangeable. To change a prop, the parent component will need to pass a new set of props, and the child component will need to be re-rendered. Data in React flows in one direction. that is from parent to child, but not from child to parent. This means that child components cannot update or modify data on their own. They would need a parent component to make any changes and pass a new set of props to the child in order for that child to be re-rendered and show the updated data. Now, we already have our name prop, but let's say we want to add something else. Let's say we add a nickname. Not everybody has a nickname, so we won't make a default property for that. When it comes to rendering, there is also the concept of conditional rendering. Let's look at an example of that. To make use of conditional rendering, I have here inside of these curly brackets, nickname, ternary operator. Nickname is just one of the props that we pull in. From the JavaScript discussion, we know that with this ternary operator, if this results in a true, we're going to output the following, aka nickname. But if it's false, we're just going to return an empty string. In order to actually pass something, I'm going to add nickname equals powerhouse. If I were to save, we have now, good evening, Jonathan Creed, aka powerhouse, followed by the time of day. If I were to get rid of this, save, you see, good evening, Jonathan Creed, that's it, followed by current time. Now that we've gone over props, let's explain how you get that data to show up on a screen. Anything that you have inside of curly brackets tells React.js that we need to execute whatever is inside of this. So for instance, in this curly bracket, in the first curly brackets that we have, we make a call to our getTimeOfDay function, and we pass it whatever the hours are or whenever this code is ran. What happens? We call this function. It does what it needs to do and returns us the proper string. And that string gets put here. Next, we take our name, which is just a property inside of props, and we output it. In our final block here, as described before, we have our nickname. Remember, any value that is not false, undefined, null, zero, nan, or an empty string will actually end up returning true. Our nickname actually has something in it. So, ternary operator is, we're outputting our true statement, aka nickname. These backticks here are just another way of creating a string. It makes it easier for us to actually put variable names in there. Another way of doing this is with string concatenation, aka space plus nickname. But me personally, I like using backticks, so we'll change this back. The final thing we need to output is this formatter.format passing in our date. Remember, in order to make use of variables that you're creating, you need to make sure to surround whatever that variable is inside of curly brackets. This tells React that whatever is inside of here needs to get executed. To start off our discussion of states, let's set the stage. Remember that local variables do not persist between renders. When React renders a component, all variables start from their default values. This includes on re-renders. Changes to local variables also do not trigger renders, as they do not have what is known as reactive values. The concept of state handles both of these issues. When we need values to persist between renders, we use state. Updates to state triggers a re-render, as state only contains reactive values. A reactive value is just something that React knows that when this value changes, we need to trigger a re-render. Let's establish a definition. State and React are the built-in values in a component. Changes to these values can trigger a re-render, and that state can have as many values as we want. As stated before, state becomes important because local variables do not persist between renders. This makes it so that we can carry on data from one render to the next. This becomes important when you start talking about the concept of interactivity. As you can see on my screen, we have our same greeter component, but I've made a few changes, namely in our app.js file. To note the most important changes that we've made, instead of a name and a nickname, I've opted to create an object. That object is going to contain both the name and the nickname. Here on line 9, we're going to create our state variables. The syntax. In brackets, we have what will be the name of that state variable. The second entry that you see here will be what is known as our setter. Our setter being just a method that, as its name implies, just sets the value for name data. General rule of thumb for creating setters, they begin with set, and they are camel case. Equals, this is a hook in React called useState, which just simply returns a stateful value and a function to update it. We can set up an initial value, an initial state. Since we're going to be using an object, I have an empty object here. If we come down to line 13 here, I've set up a conditional render, nameData.name, ternary operator. If we have a name set, what we're going to do is return our greeter component here. In that greeter component, we've made some changes. I've given it a class name. This class name is just for some CSS styling to make things look a little nicer on the screen. Name equals nameData.name inside of curly brackets. Remember, this is to denote we want to pull the value and assign it to whatever we're assigning it to, or place it wherever we're placing it. Nickname equals nameData.nickname. I've also created another component, nameForm. In that nameForm, we're going to pass this set method that we have here and pass it to the nameForm. Taking a look inside nameForm, what you see is we have a component here, nameForm. We have our component that has the properties class name and set name data. Inside, we create a function called handleOnClick. What we're going to return is a grid, a CSS grid. I'll put both of these on screen at the same time to help make visualizing this a little bit easier. I have div class name equals class name that we pass in. That class name is going to be nameForm. We're going to create a label, a simple label called name. And we're going to set it up for this input field that we have here, which will represent our name. We do the same thing, but for nickname as well. On line 23, I have a button. That button has what's known as an event handler. The event handler onClick, and we're going to assign it a function that we create. We're also going to have that button have the text update name. If we go up here to our onClick function, what this function does is first, it pulls the name and the nickname using the DOM methods, document.getElementById, name and nickname. As you can see here, I have an ID name and an ID nickname. So when these two methods execute, what we're going to do is look in the DOM, look for an element called name with the ID name, and we're going to pull its value and assign it to this variable here. Well, to their corresponding variables. Next, I'm going to create an object called name data. It'll have the property name and the property nickname, which we're going to give it from the variables that we created on lines 5 and 6. Now, we're going to call set name data and pass it that name data that we just created. The reason that we do it this way is because name is something that's going to be needed by both the name form and the greeter. So when we're setting up our state, since both of those components are on the same level and they're going to need the same value that comes from name, what we're going to do is we're going to establish our state inside of the parent component, which in this case would be the app component. This way, we can simply pass in the name data, and if they need to set that name data, since name form is going to actually be changing the name, we'll pass it the setter. And since the greeter is going to be actually making use of that name, of the name data, we'll pass it the name data that is needed. Another way, if we want to make things a bit cleaner, is we could simply pass that entire object, this name data object, if we were to just pass that to the greeter component as a property called greeting. As you can see here, I just got rid of name and nickname and replaced it with greeting. This is an object, so we know that greeting will contain a name and it will also contain a nickname. The end result of this, as you can see here, there have been some changes that have been made to our application that have been outputted to the screen. We have our two input fields here, name and nickname, and we also have this button for updating the name. What you'll see is here I've added some new data. So as we can see here, our current message is, "Good evening, Jonathan Creed, aka Tech Construct. It is currently Tuesday, January 9th, 2024, 6:39 p.m. If I click this update button here, we now see, "Good evening, Igni Volser, aka Little Flame," followed by the output of our date field. This starts to lead us into our talk of interactivity. Front-end languages aren't very fun without interactivity. We can create interactivity through what is known as event handlers. Examples of event handlers is one that we've used already, onClick. As in, for this particular element, when we click it, we're going to run some type of code. We're going to do something. You can also put an onClick on just about anything. For instance, if I were to make it so, I could make it so that if I were to click anywhere on this page, an alert would pop up saying, "You've clicked on the screen X number of times." We also have events like onChange. So if we wanted to do something, let's say if we wanted to do something really annoying, like make it so that we will randomly pick a color based off of some metric, that as we type, as I'm doing this, for every letter that I've entered, the screen color would change. Quick aside, don't ever do anything like that. As stated, this is what event handling is. Given some particular event, we're going to handle that with some particular form of handling. So, to put a definition to that, event handlers are just functions that add interactivity to apps. We can create our own for our own components. As you can see, I've done here. Typical nomenclature for event handlers. Event handlers start with handle. As you can see that I have here, handle onClick handle on change, so on and so forth. They are also defined in our components. I wanted to briefly touch on hooks. Hooks are a means of connecting into React features such as state and lifecycle methods. On the screen, I have 6 hooks that are built into React. There is the hook that we should be familiar with at this point, the state hook. You use a state hook by using useState, which declares a state variable that you can update directly. You also have context hooks, which are used by using useContext, which reads and subscribes to a context. Context lets a component receive information from distant parents without passing it as props. An example being, if you wish to implement a dark mode theme for your app, you can pass the theme to all components below, no matter how deep down in the UI tree they go. We have ref hooks, which are used by using setRef, declares a ref. You can hold any value in it, but most often is used to hold a DOM node. Ref lets a component hold some information that isn't used for rendering, like a DOM node or a timeout ID. Unlike state, updating ref doesn't re-render our components. They're an escape hatch that allows you to operate outside of the React systems. We have effect hooks, denoted by the usage of useEffect, which allows us to connect a component to an external system. Effects let a component connect to and sync with external systems. This includes dealing with, let's say, a network, browser, the DOM, animations, and other non-React code. Effects are another escape hatch that lets you operate outside of the React system. There are 2 very common cases where you do not need effects. Effects are not needed to transform data for rendering, and effects are not needed to handle user events. We have performance hooks. There are 2. We have useMemo to cache the result of an expensive calculation, and we also have useCallback, which is used to cache a function definition before it's passed down to an optimized component. Performance hooks are used as a means to further optimize our code. Performance hooks allow us to skip calculations and unnecessary re-rendering. And lastly on our list, we have resource hooks, which are denoted by the usage of just a simple use word. Lets you read the value of a resource like a promise or a context. Resources can be accessed by a component without having them as a part of their state. For example, the value of a promise or the styling information from a context can be read and stored using use. You can even create your own hooks. Like so, I can create a hook called use online status. Hooks are functions just like components, and like components, they should have purity, meaning they should be pure functions. Hook names always start with use, as you see here as I have on line 20. Something to note about custom hooks is that custom hooks allow for the sharing of stateful logic, but not the state itself. This is because each hook is completely independent from every other call to the same hook. If you've made it this far in the video, give yourself a round of applause. To finish up, we're going to bring together everything that we've learned in this course thus far. And what better way to do that than by playing a fun game? I created a little game in React that a lot of people should know, rock, paper, scissors. So, as we see here, we have our rock option, our paper option, and our scissors option. How this works is we click on one of these images, and what ends up happening is, as you see here, I clicked on paper. So the computer made a selection as well, and paper was picked. So paper and paper cancel out, so no one wins, and it's a draw. Now, if I click rock, CPU is still using paper, so the CPU wins. If I click rock again, it picks scissors this time, so I win. And so on and so forth. For this project, I ended up creating a brand new project, Rock, Paper, Scissors, which houses the app that we just saw. Everything is pretty much normal here, except we have some different components, some assets, and this utils.js file. So let's start in our app component. To explain what's going on in this file, line 1, you see we're importing our style sheet. Line 3 and 4, we are importing our components, board and footer. Line 5, we're going to make use of state by importing the useState hook from React. Inside of our app component, we're going to create a winner state variable. And what we're going to return is a CSS grid that will contain our board and the footer. As you can see with the footer line here, we are making use of conditional rendering. If a winner hasn't been determined, then we aren't going to show this footer. As you saw in the very beginning, where as soon as you land on the page, you just see the 3 options that the user can pick. But upon a winner being determined, this statement becomes true, and we're going to output a footer component. So let's go inside of the board component first. Inside of our board component, we're first going to import another component that I created called the image card. This component represents the actual images that we saw on the screen. We're importing useState, but I am also on line 3, I'm going to import 2 functions from my utils file. In that utils file, I just have a simple method for randomly selecting the CPU option and a method to determine the winner. Pretty simple stuff here. Inside of our board component looks for a setWinner function. That is set here on line 12, setWinner equals setWinner. That setWinner is the setter that we created with useState. We create an event handler, handle image click, which takes in a player selection. Inside of this function, let CPU selection equals select CPU option, which, as we saw, just simply randomly determines between 1 and 3 an option to pick. We have our options map, which shows what those numbers correlate to. 1 is for rock, 2 is for paper, 3 is for scissors. So upon getting that, let's say we got a 2 for paper. So if CPU selection strictly equals rock, then we're going to output an image card of a rock. If it equals paper, which it does since CPU selection is 2, we're going to create an image card for paper instead. At the end of that, we set the winner by calling our determine winner function and passing whatever that result is to setWinner. Finally, we're going to return our board, which is another CSS grid. Player is also 2. Can just briefly go over the CSS a little bit. So we have a series of grids. We have our container grid, that we saw in the app. We have our board grid, which is in board, and a player grid, which is also in player. And we have some stylings for the divider that divides the player options from the CPU option. Some stylings for the image to make everything fit, and for the container as well, which gives us that golden border and the graphite background. Our board here is divided up into 3 sections. We have our player section. We have the section for the divider, which is conditionally rendered. It depends on if a CPU selection has been made. And we also have a section for what the CPU selects. We're going to go into the exact order that this works. So you land on the page, and the only thing that you have are those 3 cards, as denoted here. Since there's no CPU selection, we're just going to return in our board div, we're just going to return this player grid here, which has our 3 image cards. Our image card has the prop image name, rock. Our image card has the following properties: image name, which you can see is just rock, paper, or scissors, and handle image click, where we pass it our event handler. You arrive on the page, you click on an image. What's going to happen first is on click, our event fires here. We get the CPU selection, and then we set that CPU selection. This is going to trigger a render and then a commit. And since we now have a CPU selection, we are going to now set the winner. Set the winner. We must first call the determine winner. So for instance, player selection is rock, CPU selection is scissors. The player would win, so we're going to set the winner, which causes us to come back to our app component here. Since our winner has been set, which is our state variable here, we're going to trigger a re-render. We're going to render our footer component, and then we're going to finally commit that component to the screen. Remember, rendering happens in 3 steps. First step is to trigger a render. This can happen on the initial render, as when we first go to the page, and a re-render when a state variable has been updated. Next is the rendering, which is just the creation of our component. And finally, we're going to commit that component so that it pops up on the screen. If we go into our board, you saw that we have an image card. That image card is really simple. So we're going to import our 3 images: rock dark, paper dark, scissors dark. Given an image name, the first thing we're going to do, we create a variable called image source. If image name strictly equals a string rock, image source is going to equal rock dark, and so on and so forth for the other options as well. Paper, we're going to grab this asset here. Scissors, we're going to grab this asset here. What we're going to return is a div which contains the image element, where the class name, this is for CSS handlings. The source is going to be the same source that we created here, which will contain either rock dark, paper dark, or scissors dark. We have an alt. If no image is found, we just output this on the screen. And our on click, we're going to create an arrow function where if the handle image click has been passed in, then we're going to simply call that passing in the image name. This is what allows us to make this call here for handle image click. That is where that player selection comes from. The last bit is just our footer. Our footer has props, which has winner inside of it. We're simply going to return a div, which contains another div, which contains a paragraph element where winner equals whomever the winner is. Winner can be the player, winner can be the CPU, or it can be a draw. Hopefully you found this course useful. I wanted to provide as much information as I could to help you hit the ground running in the world of React development. I wanted to give enough information, but not so much that it's overwhelming, and this course would take something like 12 hours. Because when it comes to learning React.js, Vue.js, Angular.js, or even TypeScript, your understanding of JavaScript is going to be the make or break portion for you, because all of those different flavors of JavaScript are just that. They're different flavors of JavaScript. Now, React, Vue, and Angular, these are different libraries for JavaScript. Whereas TypeScript is basically just JavaScript with syntax for types. As stated before, hopefully you found this course useful. Feedback is greatly appreciated. The plan for this year, I definitely want to do a course on Rust, Python, and TypeScript. And I also may do a few others on Java and cloud infrastructure. So AWS and GCP. There's also Azure as well. And with that, we will end this tutorial. Have a great day. And if you have any questions, feel free to leave them in the comments below. I'll try my hardest to answer as many comments as I can. Thanks for watching, and take care.